Hello everyone, today we are going to look at the circuit of a mailbox reading reminder. The structure of this circuit is relatively simple. It mainly uses the switching function of a photosensitive triode and an ordinary triode. It is used as a reminder when a letter is put in. Of course, the practicality of this circuit may not be that strong now. We mainly use it to understand the photosensitive triode. The function of the tube. The photosensitive triode tube is a relatively common light-sensing device in the early days. Similar functions include photoresistors, photodiodes, etc. The functions of these types of components are basically the same. It is mainly used to sense the intensity changes of external light to control the work of the subsequent circuits. First, let's have a general understanding of the structure of the photosensitive triode tube and its working principle. This is the physical picture of a photosensitive triode. It is encapsulated in metal and has a glass lens on the top. This is the entrance for light. It has two pins on the outside, which are the emitter wing of the triode and its electrode C. So its entrance is actually the GGB of the internal triode that controls it. Its interior is composed of a diode and a triode. The diode is actually a photodiode, so the incident light is actually controlled by the internal photodiode. When the external light intensity changes, the phototransistor controls the current change of the internal transistor GG, which changes the resistance between the inner group between the emitter and the electrode of the output, thereby controlling the following. Let's take a look at the working process of this circuit. When the power switch is turned on, the battery will provide voltage to the light-emitting diode through a resistor. Under normal circumstances, the light from the light-emitting diode will directly enter the window of the photoelectric triode. Then when it senses the incident light, its emitter E and electrode C is in the conduction state. So at this time, when the bright triode is turned on, this pin is low level because it is directly connected to ground. This place is the low level. The first triode 9014 behind it is an NPN triode. When its positive is low level 0, it is in the cutoff state. When it is in the cutoff state, then this point it is equivalent to grounding through R3. The situation of the rear triode VT3 is that the 8050 is also an NPN triode. Since the positive potential is also 0 and low level, the triode is also in a cutoff state. Then this triode is not conducting. There is a light-emitting diode and a wind insulator B at the back. These two are not it is connected, so there is no reminder effect. When the letter is put in, the light path between the light-emitting diode and the photoelectric triode will be blocked. At this time, because the photoelectric triode cannot receive the light, the resistance between its emitter level and the electrode level will become larger. At this time, it is equivalent to an internal resistance, which is equivalent to an infinity state. At this time, the positive electrode of the power supply will enter the pole of the second triode VT2 through the resistor R2. At this time, its pole will become a high level. Because the N-frequency triode is in a conductive state when its pole is at a high level, the subsequent triode will pass through this triode from the positive pole of the power supply and then pass here. Then the poles of the two three-stage tubes 8050 will also become high level. Then at this time, the three-stage tube of VT3 and 8050 will conduct. After the three-stage tube is turned on, the current will pass through the three-stage tube and then through the lead and wind detector at the back. At this time, the lead will light up and the wind detector will make a sound to alarm. When the front letter is opened, the light will enter the window of the light triode again and the VT3 at the back will be cut off. and the light-emitting diodes and wind indicators at the back will not operate. This circuit can actually evolve into a function similar to an alarm intrusion alarm. Then the light-emitting diode can be replaced with one such as, speaking of infrared light-emitting diodes or laser diodes, the middle can be placed on both sides of the window to block the entry of light when someone enters. The wind detector and light-emitting diodes at the back will also act. Of course, this circuit is just a simple way to form the basic working process, but it also has some disadvantages because there is no automatic in the middle. These circuits include locks and delays, so when the letter is put in or the light in the middle is blocked, the wind detector and light-emitting diode at the back are always in action. The phototransistor and light-emitting diode are actually similar to the internal structure of the photocouple currently used. The photocouple also has a light-emitting component inside. It is composed of a photosensitive triode. Of course, the structure of the photosensitive triode will be more complicated and there will be more classifications, including switching characteristics, linear ones, etc. Then the photosensitive triode is also called a photoelectric triode. In the early days, its cost was relatively high. Now its cost is similar to that of photoresistors and photodiodes. In terms of use, it is slightly different. There are some differences. The photosensitive 3-stage tube has a 3-stage tube integrated inside, so it has a stage similar to an amplification function, so its sensitivity is higher than that of a photoresistor. If this circuit can be connected to a circuit similar to a wireless transmitter, it can also serve as a remote reminder. We just use this. Let's use a circuit to understand the function of this photosensitive triode. So its model is 3do31. The 3 in front is more obvious. The name 3 of this domestic model represents the meaning of triode. Therefore, a large part of the photosensitive triode is a domestic model. In the early days, it was more commonly used. Well, today's video ends here. Thank you for watching. Goodbye.